Hello, everyone, and welcome to this podcast from the Light Review. And I'm very happy to say that today we're going to be looking at what is possibly a new technology, new optical technology for some of you. It's a product and a way of doing things that I've been watching for the last 5 or 6 years. And I first saw it in action in 2018 over in Frankfurt at Light and Building. And Quarkstar have given us a couple of people to speak to today, and I'm going to introduce Wilson Dau of Dau Design and Consulting Limited. Both these guys are in British Columbia, by the way, just so that if you want to actually place them on the planet, that's where they are. And also Ingo Speier of GaiaPhotonics. And these guys have been sort of principal to the development of the Quarkstar waveguide technology. So, Wilson, if you wouldn't mind me starting with you, because you're in the top left-hand corner of my screen, and that seems to be tidy. Explain to us a little bit about who you are, what you do, and what it was that you brought to the Quarkstar party.
Okay. First of all, thanks, John, for having us here. This is really cool, really exciting. As you said, my name is Wilson Dau, Dau Design and Consulting, and what I do is I basically translate client needs into things that our manufacturers can create and develop as products. So most of my experience has been both from the manufacturer side, but also as a lighting designer and as a consultant in architectural projects. So I kind of speak both languages, if you will, the language of the manufacturer and the product definition, and at the same time I kind of understand what our architects and what our interior designers and what our lighting designers and engineers are interested in terms of what the lighting should be for a particular space. So my role within this group has been to kind of guide the product definition of what is it that makes the technology that we have in hand excel at a particular application that we want to accomplish or that we want to address.
Excellent. Wilson, I think you and me do the same work sometimes from the sound of that. Putting people together. Ingo, from your side of things, I think you were more in the development side of things, were you? Is that right, or I misunderstood that?
Yes, that is fully correct there, John. And thank you for Wilson to open this up nicely for me. So Wilson looks in the market. Wilson looks at the manufacturers and see what is the need, what segment should we go after, and how are we going to do this. And then I get the specification to look at it and say, how are we going to do this technically? So my team at the end, I was leading basically the engineering team here in Victoria, in British Columbia for Quarkstar. And we were then developing a technology, which is the edge technology, which we followed through, and try to implement what we thought was necessary in the market, which was and we looked at the optical technology that would meet the needs of the market. And so we would then basically come up with a technology, follow it along, and bring it to production. So that's where my expertise comes in, is basically the development, the engineering side of implementing the specs and providing for a client basically a product that they can bring to market and sell.
Excellent. Okay. What's going to happen during the course of our chat today is that Quarkstar very kindly sort of sent me a load of slides over so that we've got some pictures, so that we don't have to sort of wave our arms around trying to describe what this product actually looks like. But I'm now going to ask you, what does this product actually look like? It's because it's a waveguide technology. It's a way of getting light from one place to another very efficiently. I'm going to ask Ingo on this one, because we've always bent light around places and we've always bounced light off different surfaces. So what was the crucial element, if you like, that created the Quarkstar waveguide product? What is it that enabled you to do this?
Well, it's I'll start with a little story on this basically because Wilson joined the team before I did actually, and was it 2010 Wilson? And then shortly after, both Bob Gardner and I joined the team from an engineering perspective, and we got together here in Victoria, and we started boiling the ocean. And what do we do for meeting the markets? Because Lewis had the idea. We're going to put visionaries together. We're going to figure out new solutions to this. So we had time at hand. We got given the time and opportunity to think through the issues that are there. So we were looking at technologies at hand and discussing how could we meet all the needs of the industry. And when we came up with the EdgeX technology that popped in our mind on that meeting in 2011, that was basically January, and we sketched it out and we're like, hey, this is new. This is great because it's what it really does. We have a coupling optic in the system that takes efficiently the light from the LEDs. Then we have this transfer optic, which is the waveguide. And that transfer of the waveguide is only used to transfer the light away from the LEDs, away from the heat, from the mechanical constraints to a new location that mixes the light on the way. And at the final location, the outcoupling location, we're going to shape the beam to whatever application we need. Symmetric, asymmetric, grazing, all kinds of, we have a lot of design freedom now because we're no longer constrained by the thermomechanical design constraints of the LED around the LEDs. So we're now in a different location, and there we can play with optics. And that was basically, that's the whole idea. And we pursued that for a number of years, and we have been implementing it in very different amount of prototypes in different sectors, as you said. And we ended up taking this technology then to market as well and bring it into production and installing it in the Museum of Fine Arts in Houston. So that was
the idea of pushing light into a solid and getting it to go through that solid and come out the other end still being very efficient. It's an acrylic waveguide, isn't it?
It is an acrylic waveguide.
But was that an acrylic where you were just able to say, well, we can use that because that tricky part has already been done for us, or did you have to go into the plastics industry to say we need you to give us this kind of transmittance and this kind of purity?
No, that the acrylic part was already done, so that was already given.
Okay.
So the light guide portion is understood, and we all know it's very efficient because you have total internal reflection. You can move light very, very efficiently along the guide as long as you don't have many scratches or damages or blemishes on the material, right?
Yeah. Wilson, the lighting industry is strewn with people who came up with solutions where there wasn't a problem. Yeah, we all know that one. So when this was sort of first put on the table to you, to what extent was there that why would you possibly want to do this, or was the conversation so obvious that you went, well, of course we want to do this. It's a new source. We can do light differently from the way we've ever done it before. Why wouldn't we want to do this? How did it fit for you?
Well, you have to kind of put yourself back 10 years ago. That's the key thing, right? Like today, if you're really into the lighting industry, you see a number of new and improved lighting control technologies that exist in 2022. But back in 2010, 2011, the mindset was we're going to replace a fluorescent tube and we're just going to stick a fluorescent tube that is made out of LEDs, and then we're going to keep the same fixture that we had for the last 20 years. And that's kind of the extent of what LEDs are going to be for us. So obviously at that moment when we said, hey, we can actually miniaturize pretty much anything that we're doing, and we can get, a linear fixture that right now might be 30 centimeters wide or 20 centimeters wide, and we can make this into something that is 10 centimeters wide. That's going to make a huge impact. And the control of the optical beams, instead of having, again, this enormous amount of material and reflectors and lenses and things to actually control the light to do a particular distribution. We're going to do this in something that it's, 2 centimeters, an inch or less in size. This is definitely something that can make a huge difference in the marketplace.
And we were talking at that time about what's the shape of an LED light? What is an LED form factor? And yeah, we were surrounded by people who said it's the same as everybody. It's the same as every form factor you've ever seen.
Yeah.
You go, no, there has to be something new here. The linearity what hadn't really been picked up on to this extent. Am I right in thinking that and I'm guessing this could have been, no pun intended, the low-hanging fruit for Quarkstar was the horticultural market? Was it easy to get out into that marketplace because lack of heat and all the rest of it, and being able to sort of bury a waveguide system inside the greenery? Or am I putting something on that is bigger than it was?
I'm going to say that horticultural market is very different from all of the architectural markets, and I think it is mostly driven by price and cost rather than performance. So while yes, this would have a great application, especially for vertical farming, I think that the mindset of the people that live in that market is not one of we're just going to go for the best product. They're just going to go for whatever is the lowest initial cost to make.
That was very diplomatic of you, Wilson.
Yeah.
I've chaired a couple of horticultural conferences, lighting conferences, and yeah, you're absolutely right. Yeah.
And I can echo that with Wilson as well, especially at that time. We're talking about 2012, 2013, 14, 15. LED prices were still way too high to compete with the other sources in the horticultural field.
Sure.
So while from a conceptual point of view it looked good, that was just the market wasn't ready from a cost perspective for that.
Yeah, it's well, I think if talking about horticultural lighting and its view of the future, I think that's a whole nother conversation. Yep. So we can park that one over there somewhere. It wasn't so long before the awareness came about that people started to understand what could be done. I was seriously impressed with the wall washing capabilities and the museum and gallery applications there. Did I read that came from the architect? Was it the architect that was when they said we've seen this stuff and we'd like it?
It was actually the lighting designers. We had a meeting where we presented the technology to L'Observatoire in early 2016. And they were already involved on the project, and they were looking for a solution to being able to light these 17-foot walls, or I think the criteria at the time where they needed uniformity across a 17-foot height. And we brought a sample at this initial meeting, and we did a full demo for them of what it did back then. And that was the initial point of engagement. We didn't know when we walked into their offices that they were looking explicitly for this. We were talking about the technology as a whole with the wall washer as our sample, and it just clicked at that moment with L'Observatoire that, hey, this is exactly what we're looking for this high-profile project that we have in front of us. So let's work together and let's make sure that it actually comes to fruition.
But yeah, I have to say that the idea of the linear LED and let's just picture lighting on any scale changed the game for artwork lighting. But seeing what's possible through the waveguide principle, and just being able to tidy everything up and to make it that much more efficient, just shows that it's not just a case of, oh well, we'll just stick a strip of LEDs in a little tube and that'll do it fine. It'll do it, but it won't do it fine.
Yes.
And that work that you put into that, I thought that was extraordinary. Can I get on to there's a big thing going on in Europe, and I'm sure you're hearing it from your own local markets, but there's an awful lot of awareness now that what lighting is, particularly LEDs, because you put all the money up front and then you just let it run for years, and it becomes an asset within a building. And so people start to see lighting as part of asset management, which means that they don't just look at the cost of it. The horticultural market, please take note. They don't just look at the cost of it at the beginning. They look at how long it's going to work and what happens at the end. And again, let's go back those 10 years and realize that an awful lot of LEDs 10 years ago, once the LEDs were exhausted or the driver had failed, that's a complete refit. That's a whole new installation. Here we are in the UK and also in the EU, and there's a lot of work now going on into circular economy, the remanufacturing principle, the idea that ideally, dare I say this, all you have to do is you change the bulb, so you can just drop out a light engine and you can put a new light engine in. Absolutely fantastic. Is that something, Ingo? This is because this is, I think this is on your desk, if anywhere.
Looks like it.
What do you? I can imagine 10 years ago that this would not have been a primary conversation. But has that discussion started? Are we advanced? Have we solved it? Can we actually look at Quarkstar and say, we can put the Quarkstar installation up and we know that it'll be up there for 50 years with its changes, with replacements? Or is that a place where we still need to go? It's a serious question, and I think it's one that we do need. And I do not always expect a manufacturer to be able to say, yeah, we've cracked it, because I don't always believe that. But it's good to know where the conversation's going. So I'm not trying to put you on the spot here. It's just so. What was the conversation? What has the conversation sounded like for Quarkstar on this?
I think when we looked at the design for the system, we had not thought about a bulb replacement system, because at this time, still, if you think back, everything prior, or the prior industry of lighting, had always a bulb model versus a luminaire model, right?
Yeah.
And bulb replacement model, and we moved completely away from that model to an integrated system. So I think when we're looking back, the industry shifted to an integrated system with LEDs in it. Now, if you're looking at the design that we brought to market, worked on with El Observatoire and installed, that system has a driver that is not on board with the LED system, with the luminaire. So there's an easy exchange for that. When if you look at most of the failures are not the chips themselves. They're usually on the electronic side, the driver's side, so they can be easily replaced. So that would have been covered, that aspect. If LEDs chips would fail, then we would have a bigger issue, because then the light has to come down, boards have to be replaced. That would be bigger, so it can be done, but we have not thought that through in this aspect. If I look at some newer projects I'm working on right now, yes, we have thought in some applications that we can have an easy module replacement now. So I think you're right that the industry has moved on. Some of the areas, some of the applications have more requirements in this direction.
Yeah, I think with the linear, if you like, the miniaturization of the linear LED light line, has created it. Well, it's created an aesthetic problem, because it's provided a wonderful solution, whether it's decorative, so it's just an aluminium channel with a diffuser over the front of it, or whether it's something that's actually working, incredibly well, a beautiful piece of sophisticated engineering, Quarkstar. In order to attain that aesthetic and to maintain that aesthetic, it is the compromise is either you're going to make it bigger to make it easier to replace, so that you can actually get your fingers in and do stuff, or you have to say, if we want to maintain this quality over this number of years, the price to pay is it's going to be a little bit more difficult to replace it. But my friends, you will replace it. That is not a problem. And I think that, again, that's a conversation. And Wilson, I'm sure you have conversations with clients all the time, but this is what you need to buy into. If you're looking for this kind of quality, this, if you like, this is the price that comes with that. And what you have to remember is that over possibly 10 years, everyone will enjoy that installation. And over a matter of a week or two, we'll be doing some replacement work on it. And I think that's
Correct.
That's absolutely fine. When I saw the Sylvania downlights, which I suspect is why they want us to be talking about this today. Who can say? But that was the first time I'd actually seen, you took a straight line and you put it on a curve, and that was one of those, what problem are we trying to solve here? And of course, yeah, if you sit down and you look at it and you look up at it and you go, oh, I get it. I see what we're trying to do. It was interesting that it should come from Sylvania, because back in the day, there was a fully recessed downlight that Concorde had, where the light only came out through the ring, and there was just a flat plate in the middle. So the form was already there. But of course, that was literally a 100% downlight. Whereas the lovely idea of using the waveguide to put as much light as you want to put on it running back, and that's something which fascinates me, that this is tuned so that we can you put in the light where you want it to go. This is not just an accidental piece of aluminium that some light's bouncing off to go maybe where you want it to go. But that was how complicated was that process? These are not big fittings.
Well, if you're looking at the design, it's basically linear design wrapped in a circle. And then of course you have to compensate, because if you linear design, you have to compensate it. You have to put more light upwards, because you're spreading. Now when you circle it, it points outwards, right? You have more area to fill. You have to bring more light in the upward portions. You have to do some redesign on it. But in essence, the design stood from our very, very, very early prototype, the Q-blade. Wilson, you remember that one?
Yep.
I'm not sure if you looked at the website. The Q-blade was really unique because it was just a blade sitting in space, and there was nothing else. So the luminaire completely disappeared if there was no light on, because it was completely transparent. And I found this always the most unique solution, but somehow we have not been able to put this into a product yet. But that basically, that technology from that, we use that and we wrap this around in a circle.
Okay.
Basically, and we dropped one wing of that optic and did a bit of redesign on this, and then we had a solution for that. So
yeah. I can't believe that no designer has actually picked up on the idea that you can actually create light in space apparently from nowhere. That's just, they're just not paying attention. And as soon as they do, everybody will want one.
Yeah.
And
it disappears, right?
Yeah.
Yes. Also, you have to go back to that concept that we're talking about 10 years ago, and where, again, everybody was thinking about a tube and replacing that tube. And then this idea came about of, we can do indirect and direct lighting out of this same source, that it's just, as Ingo pointed out, basically just floating in midair in the space. And we can actually tune the amount of uplight and the amount of downlight coming out of this device. And not only the amount, but also the angles at which both the direct and the indirect distributions are going to be exiting out of that fixture. So it's kind of like a kit of Lego parts, where you could basically tune exactly what you need for the application that you need, It gives you application efficiency, which a lot of people are talking about these days, is not only the amount of light that you get out of the fixture, but where is that light going? Is it being wasted, or is it actually going onto the surfaces and the planes that you want that light to go into? And the concept of going from that linear, as Ingo pointed out, to actually just revolving it and putting it into the Concord Equinox was kind of like a flash of inspiration, if you will.
Right. But I was going to ask the extractor component of the waveguide. See, I just to show I've been doing my homework there. Thank you.
Thumbs up.
The extractor is the thing that's doing the hard work, isn't it? I mean, because that's actually that's determining where the light will be going after it's come down through the waveguide. Is that cemented in the factory, or can that be removed and replaced with a different extractor once it's in use?
At this point, it is cemented in the factory.
Yeah,
At least,
I love it when people say "at this point," because it's just make a note of that.
Yes, at least at the time that we put those that we built those, and I think Sylvania's product still has it in a cemented or in one piece at their facility now. But it is one piece. But we discussed in the past, of course, also having field replaceable optic. The issue you need to deal with, of course, is then the interfaces, because when it's cemented, and it's not easy to cement it very cleanly, you're gonna have no bubble free. It's not so easy to do, but it needs to be optically clear, clean. You don't want too much scattering out of this, because scattering will give you a glare as well. We know that you don't want that, right? So you want a very clean interface. And so if you make it field replaceable, it's going to be a challenge to do this, but it is doable. So we discussed this in the past, but we have never implemented it really yet. We did actually implement it for little handhelds, right, Wilson?
Yep.
We had those little demonstration modules we made for trade shows and clients. They were just like 4-inch long. They had like 6 LED blocks in it, and then you could place basically all the different optics on it, and you could see the different optics doing their job. So that's you just implement that solution that you did for this little demo version into a product. So it is doable.
Okay, it's one of these things that, again, galleries, museums, their displays can stay as they are for years, but then someone comes along and does a radical redesign, and you go, does all this have to go now? And we're talking about office lighting, and you are, and Quarkstar is promoting the system as an office lighting solution.
Yeah, I think, Wilson, we discussed at one point having a field kit, replacement kit. Yep. Remember that?
Yeah.
Well, we look forward to that then. I think that sounds fair.
Well, it is, as far as I understand it, it is still in the works. It's just a matter of, like Ingo said, that the main roadblock to implementing is that interface between the light guide and the extractor, making sure that that gets A, perfectly aligned, and B, that there is no light leakage in that interface, which would create, A, it loses efficiency, and B, you start getting points of glare from that extraction point. So it's still in the works.
It's a question of maintaining excellence, isn't it? Because if you let that go, then you've lost the essence of what the thing is all about. Hey, I'm going to call this, because I think that's for anyone who hasn't been aware of this product. I hope we've blown their minds, as the old hippies used to say, to find out much more about it, and we'll be putting link and email addresses and all the rest of it on the end of the video here. I'd like to thank you both, Wilson and Ingo, for your time today. I really want us to talk again, because I think there's going to be an awful lot more that we can talk about. But just to get this ball rolling, it's been a treat. Thank you very much for your time. Is anything that you want to say before we go?
Thank you, John. This has been fantastic. We really appreciate the opportunity to spread the message.
Okay, well, see you again.
Thank you, John.
Thanks very much, and goodbye.
Goodbye.
Bye-bye.